Hi, I am Chandrasekhar Gupta and we are discussing programming concepts. I want to congratulate each and every one of you for moving this so far. We have almost completed all the topics that are required in C programming or any sort of programming language. It's the right time for us to take a dive into data structures. There are many data structures, linked list, stacks, queues and so on. But everyone faced difficulty with them. We'll try to figure out an easy way for each and every one of the data structure and we'll try to understand it in a different perspective. First, I want you to introduce to linked list. I don't want you to talk about the terms node and pointer as soon as now. I want you to think it with the help of a practical scenario. Just think you along with a group of friends went to a cricket match. Unfortunately, you have got seat in the first row. Your friend has got seat in the second row and so on. You have 10 friends and they are in 10 rows respectively. You have a cookie packet. You need to pass it only to your friends. What will you do? You just pass to the person who's in the second row if you are in the first row and he passes to the person who's in the third row and so on. So here if you just see from the first node, from you are trying to make a connection to the second person or the second data. That is, in this scenario, the cookies can be analogous to data and the persons can be referred to pointers. As you remember the place or location of the second person, you tend to store the address of the next data that is being stored. Literally, you store the cookies or you send the cookies. Similarly, you send the data to each and every location in the memory. And in the similar way, how you keep track with the help of remembering the location of the next person in the next row, you will try to keep track of the next location with the help of its address. That's how a linked list works. Let's look into its practical implementation.
As we have discussed, let's say I have stored the data of student 1 at a location of 100 and data of student 2 at a location of 200, data of student 3 at a location of 300 and so on. Linked list actually tries to keep track of all the data by pointing to the next memory location, and this pointing is done by storing the next memory location at the current state or the current node. So it stores 200 here and this actually stores 300 here. If this is the final entry, then it points to the null pointer. Whenever we come across null pointer, that actually indicates the end of the list. For example, we have taken the details of all the students and a new student wants to join our school. So we need to collect the data of this student and also keep track of it. As you have seen, the registration number which was given to the student is 2, but we have someone at that place now. So if I want to do this, I have to actually insert this block of memory in this position. For doing that, I can actually make it point to this location, and if this points to the next location, automatically the numbers will be adjusted. Now this is the first block, this is the second block, this is the third block and so on. If you might have seen, by making a couple of changes in the address, if this is at a location 250, let's say, instead of 200, we have stored 250 here, and at the end of it, as the next address is 200, here we have tried to store 200. By making a small change, we have actually incorporated a new student successfully. Let's take one more instance where this new student is not happy with our school and he wants to leave. So his details are no longer required and can be eliminated. For this, I just need to make it point to the previous node. When I change this address and I revert back to 200, this actually points to this location and this link will be erased. As we start with the starting address, from here I am reaching the second student and from there I am moving further. So there is no track of this student and the memory which is allocated to this student or his details can be removed from our system. We need to observe that in the case of practical scenarios, especially in the real world scenarios, the situations like this will occur very frequently and it is very easy to keep track of them with the help of linked list. Suppose, for example, if you have used arrays to store the information of the students, let's say we have used an array of structures. We know that structures is used to group all the details. So we have used a structure to group all the details of a student, and we have used array of them: student 1, student 2, student 3. Now a particular student 2 wants to enter our school. His details has to be filled. All the elements which are after 1 has to be moved to the next location, and this has to be inserted at this place. There are two factors here. First one being availability of memory, and second one is costly operations. The same happens even in the case of deletion. Suppose if this student has to be removed, all the student details which are after that has to be moved to the forward location. So if we try to use array of structures, or if we try to work with array data structure in real world scenarios, it may not work always. That is why we try to use linked lists. Let's have a quick recap. Why are we using linked lists? First one being lack of contiguous memory locations. For example, if you take an array and if you want to store the details of 100 students, and one student, let's say, is taking 10 MB, we know that array actually looks after contiguous memory locations. It is difficult to find size of 1 GB continuously. In that case, linked list can come to our rescue. We can actually allocate a memory block at an instance, and we can point to the next address where another details can be stored. As we have already discussed, insertion and deletion is also a factor. So in the real world scenarios where people tend to use insertion and deletion a lot, linked list is having more advantage over arrays. And also it is dynamic data structure. You can allocate the memory whenever it is required with the help of malloc, calloc or realloc library functions.
Right now, everything seems so positive about linked lists. But if it is the case, why do arrays exist? Why we have not replaced arrays completely with linked lists? Let's have a look.
Even linked list is having some disadvantages. First one is extra space for memory location. If we just observe, we are trying to store the data, and then we are also trying to store the next memory location. So the location at which this is stored is also being stored. That is, we are allocating extra space for storing memory location of the next element, which is generally tend to wastage. And it is possible to have only sequential access. Let's take a linked list and an array. If I want to access this element, I can access it directly with a of 1. But if I want to access this element, I have to start from the beginning of array and I have to go in sequence. That is the only way. And the address of the first node is actually represented in a head pointer. So head pointer actually provides us the entry to the linked list, and then we'll move further. If we have lost head pointer, then we cannot actually keep track of any node and the entire list will be at stake. This is a disadvantage of the linked list, and it is also not cache friendly. In the case of array, while you are dealing with a particular word, it's most probable that you may deal with the next word because of the locality of reference. So you store all of this in the memory or in the cache. But in the case of linked list, as each and every one of them are at different memory location, it is not so cache friendly.